Good morning, good afternoon, good evening, depending on your geographic location. How are you doing today? This is Pranav from DBS Diary, and we have a few videos where we talked about interviews of SQL Server and Sybase ASC, and there are other videos of Sybase. So today we'll talk about SQL Server indexing, how it helps, and how should you design the index. Okay, like if you start from scratch, there is no index at all on the table, and you have been given assignment that you have to design the index. Okay, in certain cases you know what are the queries which will hit your database, and in some case you do not know that. Okay, but you have data. Okay, so we'll start with the indexing and we'll see how it improves the performance of query and how it will also help in blocking, deadlock and other thing. We'll not cover much detail about the blocking and deadlocking today, but we'll cover about indexing. Okay, so let's start. Okay, so I'm going to work on the Stack Overflow database, which you know very well. So this contains actually list of tables, which you know, like this table contains what? I mean, if you have, say for example, batch table, comment table, link, post history, users, posts. So this actually contains what you actually it is supposed to contain. Like user contains information about the users, right? Post contains information about the posts. Then we have vote. So you know, like it is up voting, down voting. Then there is vote for closing the question. Okay, so all these things are stored in this. So today in this session we will cover the table users, and we'll see how it starts and how it helps in terms of indexing, in terms of performance, in terms of logical read, in terms of time. We'll not cover too much of time today, but we'll see like logical reads. Okay, so let's start with the lab. So first thing that we'll do is we'll drop all the indexes. This drop indexes is not my procedure. This is developed and maintained by Brent Ozar, which you know he is SMA of SQL Server. I follow him blindly, and I'm a big fan of him. I have learned a lot from him and his team, like Mr. Eric Darling and others. Okay, so let's start. So first thing that I did is drop index. So whatever indexes were there in our database, it has been dropped. Okay, other than clustered index. Okay, then we'll just do like free proc cache, so there will not be anything in the cache. So we'll start fresh. Okay, and now we'll do the set statistics IO on, not off, so that we'll know like how many logical read has been done, right? Okay, so first query is on the users. So we'll put a query like random query where reputation is equal to 500, and we'll enable the actual execution plan. You can either click here or you can click like Control M, and this will be enabled. So I did Control M. Now you see it is like highlighted, so it means it has been enabled. Okay, so now execute this query and see. It took like around 1 second, so time is not that much, but let's see the logical read. You will see the logical read is 142,000 pages it has read. So in order to get this much record, what it had to do is it had to read 142,000 pages from the disk. Okay, so you see it is clustered index scan. So we have clustered index on this table. Other than that, we don't have any index. Okay, so it's doing clustered index scan. Now just imagine in terms of this, if we had an index, how it will work out. Okay, now suppose let's go with one more query, and before we go ahead and see, let's see how many rows it has. Okay, so 142,000 pages, and if you see number of rows it has done, if you see number of rows read here, you can go and click on the properties, so you will know all the details here. Actual number of rows for all the execution. Then you will see IO statistics, so you see number of logical reads here. Okay, and similarly you can also see in terms of pages here, IO statistics, other things are there. Okay, so 8917507, which is actually the number of rows. So if we use sp underscore space used and users, which is the table name, so you will see this much rows are there. So in order to get you the result, it had to read the complete table. Okay. Now let's run another query and see how it goes. So select start from users where reputation is equal to 500. So we are not changing the condition of reputation. What we are adding is one column here for location. Okay. So in this way, see, we are having only 6 rows. Only 6 rows have been returned as a result. Should it do cluster index scan? Should it spend that much time? Should it read this much rows? Is it really required? No, it's not required. So what should we do? We should support them with the index, right? So now what we'll do, we'll create the index on reputation column. Now you may ask me why not on the why not to create index on location column. Okay, so if you see reputation, actually we'll cover more in terms of blocking detail, blocking deadlock and other thing. Why should we create index on which column and how it will help to prevent the blocking. When you have blocking, then it could result in deadlock. Okay, so why should we create index on reputation and not on the location column, and in which case it will support and in which case it may not support. Okay, so let's go one by one. Let's create index on location column now. Okay, so now you see it has been created. Now if we run the same query which we ran first time, which is select star from users where reputation is equal to 500. So in this case, if you see, it had to read only 1000 pages and it didn't have to read the 141,000 page. If you see the plan here, okay, so it is using our index and it is doing index seek. So 359 rows are there, you can see here. You can see here 359 rows have been read. Okay, and it did like key lookup because it had to get other columns. It would be if you put only reputation in this, which we don't use in real life. If you do this, then how it will look like? It will be index seek because this index contains only one column. So if you use only that column in the select, then it will use only index seek. It doesn't need to use anything else. It doesn't have to go back to primary key or cluster index to fetch the other columns. Okay, now the same query which you ran before, now let's run this after the index has been created. So let's see, we had only 6 rows, right? So for getting 6 rows now, it has to do only 1000 pages because we have index on reputation column. Okay, so it is doing index seek on this one and then it is doing lookup. Okay, so it has to get 359 rows because we don't have supporting index on location column. That is why it has to find the rows which is matching with the reputation first and then it has to find the India location. Okay, so here actually we are doing more number of pages read, but it's very minimal. So only 1000 pages, so it is very much acceptable if you have only one index in place which is on reputation column. Now let's think about this. See, before we used equality operator, right, where equal to. Now let's use inequality operator. Now inequality operator is, it could be greater than equal to, it could be greater than, it could be less than, it could be not in, it could be a lot of things are there, not exist. Okay, so if you run this query, now let's see what is happening now. Now it has gone back to cluster index scan. Okay, so it is reading the complete table. If you see the logical page here, it's back to 142,000 pages, right? Okay, now what we'll do, now create another index, okay, to support our previous query on reputation and location. So now we have one query which is already on reputation. Okay, why we are putting reputation as the first column? Because reputation is more selective generally than location. Okay, it has some exception, like if you talk about reputation one. Okay, I will not go now because I have some other example to showcase that. Okay, so let's see this. Let's go ahead and create the index. Okay, so which will be on the reputation column plus location column. Okay, now let's run the same query which we ran before, okay, with inequality operator, and let's see what it is doing, how many pages it is reading. It's reading 11,000 pages. Okay, because it is containing inequality operator. It is using our index. Okay, but if you see number of rows read, and actual number of rows, there is difference in that. But it is still much better than not having index on location column. Or if it is there on the reputation column, since it is inequality operator, it will not be used completely. Okay, now let's go and see the next query. Okay, now think about this. Just take a moment and think what will happen. Now location is null, so here we are using inequality operator for reputation, but we are specifying location which is not specified by users. Okay, we have like thousands or hundreds of thousands of users there on the Stack Overflow. There are many who does not really like to fill the location field, so it remains null. There are very few who really goes and fills the field that they are from UK or US or Brazil or India or anywhere. Some people have more time and they go and fill more detail, like where are they belonging to, which state in US, or they are specifying what is the pin code, and in India where they are staying. So there are many things, so it depends, but most of them are lazy enough not to fill these details. So if we run this query, what will happen? Still running, as you can see. Okay, so based on time it took, it will go for, we can guess that it will go for cluster index scan. So it is reading the full table. If you see the number of page here, it will be 142,000 approximately. Okay, now think about, we are specifying one more column here, which is display name. Okay, so here we have reputation greater than equal to 1. Okay, actually I gave you a hint of reputation is equal to 1. Reputation is equal to 1 is actually most of the record in table, because there are many users who creates the account on Stack Overflow. They ask the question and then they forget about it. They don't even care to go and check the answer, whether somebody wrote the answer for them, somebody is asking comment on that. So they just ask the question, they log off, and then they just forget about it. So when you create the account on Stack Overflow, when you make your user on that, when you have a login, it assigns you a reputation of 1. So most of the users are from this category. Let's see how it behaves. Okay, so if you see the execution plan, it is again going for clustered index scan, which means it has to read the complete table, 142,000 page. Now let's think about this. Is there any way we can support this? Okay, reputation is equal to 1. Let's keep it aside a bit. Okay, but then we have location, and we are very much specific about the display name. Okay, so let's create the index here and see how it works. Now just notice here what we have done. We have two index already on the table. One is on the reputation, right? Second index we have is reputation plus location. Now this is going to be third index. Okay, this is reputation, location plus display name. Okay, let's see how it supports and how it works. Now let's run the same query. Okay, I am showing you the query before index, after index, how it works, how it improves the performance, and I will also cover later on that which index should be really part of it and which one can be dropped or should not be kept. Okay, let's run this query. So as you saw, it went very fast. Okay, so now you see it is using our index. Which index it is using? It is using the newly created index, which is reputation, location, display name. Okay, it managed to find that, and then it had to do key lookup because we have star. We are fetching all the columns. Okay, how many rows it has got? It has got only 67 rows, but it still had to do how many page read? 25,000 page read. So if you compare from the complete table read, which is 142,000 pages, and if it comes down to 25,000 pages read, it is still very good. You may not see it that much, but if you see this query is ran very frequently, so that way you will see that it has really improved a lot in terms of performance. Okay, now let's go and see the next one. Now think about it. We have one index. All the indexes are starting with the column reputation. What if we say that we should have index of only one column? So let's have this index which is on location column. Okay, do you think it will help in improving the performance of previous query? We already have three indexes, one having one column, second one is having two column, third one is having three column, and all three are starting with the same column, which is reputation. Okay, now we are going to create another index which is on location column. Okay, let's run this query, create the index and see how it goes. Okay, let's wait for a while. Doesn't take this long, but it seems to be taking, because we already have three indexes on the table. Okay, now let's run the same query and see how it works. What is this? Why it went back to clustered index scan? Why it is reading the complete table again? Whereas we already have index which we have seen already in the previous run of the query. Same query, you can see these two are exactly same query. If I drop this, there is no difference in terms of query here. The previous one used our index which was on three column, that has not been dropped. It is still there, right? It is still there. But then now when we have another index which is only on the display name column, location column, sorry, which is only on the display name. Location, on the location. So it has gone back to table scan. Cluster index scan is nothing but table scan. When it's a table, it will go for table scan. When it's a heap, it is called table scan. Okay, so it has gone back from 25,000 page reads to 142,000 pages. Why did that happen? Just think about it. Okay, how about this query? I will remove the reputation part. Okay, and let's run this query now. Why it's not using our index? Can you guess? We have query, we have indexes. We have index on location column. We also have index on reputation. We have an index on reputation plus location. We have index on reputation plus location plus display name. None of them are being used here. Any guesses? Okay, let's go and see. Now let's create another index on display name. Okay. Now let's see that query. The one which we had ran earlier. First time when we ran, it did use our index and it was 25,000 page read. Now and then when we had another index on location column, it went back to clustered index scan. It was doing full table reads. Okay. How about this query now? Now we have 5 indexes on our table. It is using our display name now. Okay, so the index which we have created is now display name, the recent index which we have created now, that is getting used in this query. And if you see the number of pages, it is reading only 4,000 pages. So this index is very, very effective for this query. In the previous query, when it was doing index scan, it was using 25,000 pages. Okay, this one is much more effective than that. But then let's see this query now. Sorry, next query, the one which we ran before, and it was doing index scan, clustered index scan. Okay, so even in this case, if you see, it is using our display name index, and it will again do the page read of only 4,000 pages. Now think about it. Okay, and let's drop the indexes on this location column, because location is not used. We saw that. Okay, and let's think about it a while now. What should we do? Should we have index on 1 column, 2 column, or 3 column, or should we have an index, 5 indexes on each column? Which one is advisable? Which one should be created on the table, which could be used by most of the queries? Okay, because index is not something which is helping all the time. It will help you only in the select operation, but it will impact performance for any write operation like insert, update, delete, as well as it will also having impact on your maintenance job. It will take longer, right? And it will also it could also cause blocking if you are performing like no rebuild operation, right? So that way you need to be considerate about number of index and number of columns in the index. Now let's drop this index on location, and let's also drop the index on display name. Let's also drop the index which was created on one column and two column. Okay, now we have only one index, right? We have only one index which is on users column, okay, which is of three columns: reputation, location, and display name. Now think about this query, how it will work. It is using our index. Yes, it is using our index. Now we can have one more query, display name, using our index. Yes, let's go back and start from the first one. Is it using our index? Yes, it is using. How about this column? How about this query? It's using our index. Certainly yes. Okay. How about the next query, which was having display name? It's using our index. Yes, for sure. So by this example, we can understand that you need to have less number of index, okay, with more number of column compared to more number of index with less number of column. This is again subjective, okay, but it again depends like which column you should pick for the indexing. You should not pick those columns which keeps on getting updated very frequently or kept on getting changed very frequently. Like you have a column here which is updated. Let me see, what is the column here? Last access date. Okay, so if you see last access date, or if you see, for example, views, okay, this will keep on changing. They could be called as hot columns. So you should avoid indexing those columns. You should take those columns as an index which makes it selective, okay, which could I mean, you can say, if you have that condition, that will filter out most of the rows in the table. Okay, for example, if you have reputation column, if you exclude one doesn't make it selective, but if you exclude one, then it is very much selective. Let me show you with the example. Okay, so I will put one condition here, otherwise this will not make much sense. Okay, now let's run this query and see how it is. If you see, it is very much selective. If you take any of them, okay, this will make it very selective, and it will go and fetch only most of the cases. It will not go more than 5%, or maximum it will not go for 10%. So in that case, it will use that, and it will be able to find to a specified number of rows, set of rows, not like it doesn't know what it is doing. And if it is on the number column like integer or any number column, indexing on that column will really have an edge compared to indexing the column which is having varchar. If you have an option, then you should create index on numeric column first, which is having number column. It could be integer, it could be number, it could be anything like that. Okay, so I hope this has helped you to understand how should you create the index, how many columns should be there in index. There is a general rule from Brent Ozar to have 5 columns in an index and have 5 index, but that, as he says, and I again repeat, it's not hard and fast rule. This is just a rule of thumb. Okay, so you should start from there, and then you should check like how the indexes are getting used, okay, and whether you need to drop some index, or there are some duplicates of indexes, or there are too many columns in an index. Suppose you have a table of like 15 columns, okay, and then you have an index of 13 column. Doesn't make any sense, right? So you should be judicious in deciding how many columns should be in index, okay, how many indexes, okay, depending. Suppose it depends on your setup also. Suppose there's a table which is mostly read only, okay, it doesn't get used for writing purpose, data warehouse, for example. So again, it depends on that. So depending on your environment, depending on your structure of table, depending on data type, depending on selectivity, depending on the query which is coming from application, you need to decide which index should be designed, okay, how many columns should be there, and then it should not happen that you create index and then you forget about it. No, you need to keep on monitoring that every month, or maybe once in a quarter, or depending on the usage. So you should keep monitoring that, and you should not monitor immediately after the server has been restarted or service has been restarted after patching. No, at least you need to have 15 days of data. I mean, even 1 week is fine, but depending on the load on the server. Okay, so I hope this has helped you in understanding how to design the index. This is very basic. It's very advanced topic. A lot of things could be discussed, but I hope I give you an idea like how should you design the index, and this could help you in starting of creating index and designing an index. Okay, so thank you for watching, and if you like my video, please like, comment and subscribe. Comments are very important, okay. There are many who are commenting that a lot of things, so that is really giving me input, and it motivates me to have more and more videos, and I will try to cover as much as possible. And if you want me to cover something very specific, do let me know through comments, okay. So thank you very much for watching, and have a nice day, have a wonderful day, have a great day. Thank you very much.